Assalamu alaikum dear students. Bismillahir Rahmanir Rahim. Welcome in lecture 15. Okay. In this lecture I am presenting you a new beam. Okay. That is also simply supported, but the beam is, you can see, is inclined. Some portion of the beam is inclined, while there is it is just only placed at this wall surface, and it is just only placed at this inclined surface. So we need to, you will understand, okay, here, that how we will assign such kind of beam, model such kind of beam, and as well as we have to rotate this joint as well, clear, as we done in lecture 14. So the beam is simple. Just I want to explain you that how we will basically model this kind of structure. Okay, so we will use their grid spacing. Let's say we have x1, x2 and x3. So in x direction we have three axes, x1, x2 and x3. Now these two axes is basically at a distance of 6 feet, and these two axes, okay, we need this horizontal distance, so we can determine this horizontal distance by this inclined length and this angle. So this is a right angle triangle, using the trigonometric relationships. This is 10. Okay, this is 10. So using trigonometrical relationship, this y distance and this x distance can be found out by 10 multiplied by cos 30, that is roundabout 8.66. okay, and this will be equals to 10 times sine of 30. Okay, and this is comes out to be 5. Okay, this angle is basically 30 degree, so we need to rotate this joint by an angle of 30 degree. Clear? So this is the whole modeling data which we will need in modeling of this frame section. 80 pound per feet loading is applied, and this is our required units. So let's start. The units, make sure the units will be in pound feet. Clear? And so make sure your unit will be pound feet. Select template using grid spacing. Check this unit. Grid spacing, we have three axes in x direction. Assuming this is, let's say, this is 1, and in z direction, we have z1, ignoring the depth of the beam, and this is z2, and we need to determine this height, and this height is determined here, that is 5 feet. This is 5 feet. Okay, so in z direction we need two axes. Let I assume this is equals to 6 feet. This y let this is 1, and the vertical height is 5. Clear? So okay, now we edit the spacing. Make sure you will be in xz plane here. Let edit the grid spacing. Okay, so spacing unit should be feet. Now the first x1 and x2, you can say this is A, this is B, and this is C. So AB spacing is 6 feet and BC spacing is 8.66. Clear? 8.66. So So AB is 6 feet, okay, and BC is 8.66. Sorry, this is 666. Clear? And the height is 5 feet, okay. The distance between Z1 and Z2 is 5 feet, okay. Now these are the grid lines. Select line element, okay. Click here, then click at a distance of 6 feet, and then click this corner, okay. So now this is your beam. You need to assign, you must know the beam is just placed here, so this is ruler support. Clear? This is ruler support, and the beam is just placed over here, so this is also a ruler support. Clear? So select this point, assign, joint, the strand, and OK. So we need to rotate this joint. Select it, assign, joint, local axis, and make sure the rotation angle is 30 degree, but the rotation is in anti-clockwise, so with a negative sign, and the rotation is about y-axis. So make sure you have to rotate the joint about y-axis, so 30 degree. Okay, the joint is assigned, and now assign the moment. Here the loading. Assign frame load, distribute it, make this equals to 0. Okay, modify, okay, and dead load, found feed, this option, global axis, direction is gravity, and you have to apply a UDL of 80 pound. Okay, because this whole span is subjected to 80 pound per feet. Okay, this is loading. Joints are assigned, beam element is drawn, loading are assigned. Let's see, we will analyze. Save it. This is project number 15. Okay, this is 82.20, this is 390.75, and I think the reactions are okay. 94.8, this is your CY, this is vertical reaction, this vertical reaction is CY, and this AY is basically 398 pound. Okay, AY. So AY 390, or you can say which is close, and this is 88.20, which is close to the exact answer. Okay, so this is the way, or this is the procedure. You can draw shear force and bending moment diagram as well. Okay, and you must know that this joint is basically hinge joint. Okay, because there it is said that A joint is basically a hinge joint. Let's see, we repeat the process, check it, unlock the structure. Okay, select the joint, assign joint, strand, hinge joint. Okay, so now this joint is the strand. You just only make these changes and then again analyze the structure. So the reaction is now okay. That is the error which we make. Okay, that is the error which I committed. So I rectify my error, because this is hinge joint. This is not just a ruler support, because it is mentioned there C, and C is a smooth support, means this is a ruler, and A is a pen joint. Pen joint means this is hinge. and B is basically sometimes there is a hinge. Okay, so B is a fixed support. Clear? So now your reactions are 100% okay. Absolutely, they are now 398, 47 and 94. This is the end of this lecture. If you have any question, any comments, please share your comments on my YouTube channel. Okay, and you can share your comments, your suggestions on my email as well as on my contact number. Watch the video and enjoy. Thank you.